Hi everyone, welcome back to a new video. In this video, we are going to talk about Graceful Shutdown, what exactly Graceful Shutdown is, why do we want Graceful Shutdown, and why not just let our application automatically get closed. We'll talk about some core concepts on how Graceful Shutdown is implemented. We'll also have a look at an example in Golang, where we will first see how an application behaves without Graceful Shutdown, and then we will implement Graceful Shutdown on that. We'll also have a look into the use cases of Graceful Shutdown, because at certain places or at certain use cases, at certain situations, Graceful Shutdown is useful. At some places, it is of no need. So we'll talk about that as well. So let's get started. Firstly, what exactly is Graceful Shutdown? So it basically is a mechanism, or it's a method through which we can stop our application not immediately, but after performing certain tasks, after which we can say that, okay, this application is now safe to shut down. What I mean by that, I'll show you through an example. For example, this is a server, and here's our client. Now we know that a client would send a request to the server, and a server would send back a response. The thing is, this is what normally happens, but what if this server goes down for some reason? For example, this server or this application was running as a Linux service and it just got restarted. Or for example, this server or this application was running as a Kubernetes pod, and we did some rollback, or we did some rolling update, or we deleted the pod for some reason. At that case, this application also goes down. But for example, if the client sent a request and before the request was received at the server's end, this server was down. So that's not a problem. Client will get a response saying the server is down, whatever. The problem is when the server is halfway through the execution. What I mean by that is when the implementation has reached the handlers. For example, if this server has a handler called, let's say, this buy product, we have a handler for this. What happens here is, firstly, we add the user in DB, and then we perform transaction. So if some client comes to our website and they want to buy some product, what we do is first we add that user in the database of users that have bought that product, and then we perform the transaction, and then let's say we ship the product. Now the thing is, for example, client sent a request to the server at this endpoint, and then server started executing using the handler, and now handler first added the user in DB, and at this point a shutdown happened. By that I mean, for example, this server was running as a Kubernetes pod and we deleted that pod at this point, at this where I've written shutdown at this point. So the user has been added in the DB, but we didn't perform the transaction. That means the user did not have to pay for the product, but he's already in the DB. So the DB is incorrect or is corrupted, and user will be getting, in his particular application or web app, user will be seeing that product as purchased or ordered, but we have not actually ordered it because we haven't performed the transaction and we haven't shipped the product. And this is one example why we would need Graceful Shutdown. So what Graceful Shutdown will do is it will perform certain tasks that will make sure that conditions like this doesn't arise. So if we do not do Graceful Shutdown and we let the application just immediately get terminated as soon as the server on which it was running gets down, this is what happens. And this was just one example. A lot of other things can happen if we immediately shut down our application. Or let's say immediate shutdown. Immediate shutdown can cause certain problems. Like first we saw was the user request getting immediately ended. I think the spelling is wrong here. Second, for example, our server was connected to some database. So immediate shutdown can lead to corrupting of DB, or for example, if our server was writing a file while it got shut down, then it can corrupt that file as well. So basically corrupting the data, which could be a file, or it could be a DB, or it could be anything. Immediate shutdown also means that if the server is connected to database, then those database connections will not be closed properly. So will not close the DB connections properly, and will not be able to perform any sort of cleanup actions if our application needs that. For example, if our application creates a file and by the end of the function, it deletes that particular file. Now, if the server is not gracefully shut down, it is immediately shut down. Then what happens is, for example, if the file is created and the server got shut down, then the file is not deleted. There is no cleanup, which can cause issues when we run the application or we restart the application. So let me note that down. No cleanups. So these are the problems with immediate shutdown. Obviously, people can have more problems. That depends upon what application is doing and how we have implemented things. But in general, these are the more important or most common problems with immediate shutdown and what graceful shutdown can fix. So with graceful shutdown, what we can do is we can complete our requests. We will not take new requests, but the requests that have been started, that are in flight, that are being executed, will be completed before we shut down our application. So with graceful shutdown, what things we can do is we can complete the in-flight requests. If there are any database connections that are not closed properly, then we can close those. DB connections can be closed properly. We can perform the cleanups. So we can do cleanups or cleanup of resources. If we have implemented some sort of locking in our resources, then we can also release locks for those resources. So release locks. What else is there? Corruption of data files. We can prevent that by ensuring that the requests are completed. We talked about this already. And one more thing I can recall is we can notify other services or whatever. So yeah, these are the things we can solve with graceful shutdown. Obviously, it's just a mechanism. The implementation depends upon your creativity, so you can do anything. But these are the general things that are done, except for the notify services one. I'm not sure if this is very widely used or not. Now let's talk about some concepts on how this will be implemented. So now let's talk about the core concepts on how we can implement graceful shutdown. But before that, one more thing. Graceful shutdown is not always the solution. Why I say that is because, for example, this server is running on a Linux machine. Now, if it was running as a Kubernetes pod, then we can say that, okay, when the pod is deleted, before it completely gets deleted, we will perform graceful shutdown. That is, we will let the request that was being handled get completed. After that, we'll do the shutdown. What if the server or the Linux machine on which it is running itself goes down? There is no graceful shutdown at that case, obviously, because the application, how will that run? How will that execute the commands that are for graceful shutdown if the machine itself on which it is running is gone? So you cannot solve everything with graceful shutdown, obviously. There are certain things we can solve, and there are some things we cannot control, like the machine itself going down. We cannot actually control that. Now let's talk about how will our application know that there is a shutdown. What I'm trying to say is, for example, we have an application. It is running on some server. Now, how will the application know that there is a problem and I need to implement graceful shutdown? So for that, we have signals. So if you want to create graceful shutdown, the first step is listen to the signals. Now, what I mean by signals, basically, whenever operating system finds some issues, it can send certain signals and you can listen to those signals to figure out, okay, so this is the case where we need graceful shutdown. This is the case where user has pressed Control C and in the terminal and the application is no more running, or when the Kubernetes container has been stopped or the pod has been deleted, and we can handle these signals accordingly. So there are different signals sent by OS depending upon what the situation is. So there is SIGTERM, which is basically signal terminate. This is mostly used by K8s, it is used by Docker, etc. So these container orchestration systems to send a signal that, okay, the container is going to stop. So if you want to perform any graceful shutdown, that this is the right time. Then there is signal for interrupt. So this is SIGINT, signal for interrupt. This usually happens when we press the Control plus C command in our terminal, or if we are using macOS, then Command plus C key. And then there are a lot more signals. Okay, this is SIG. And then there is SIG quit. This is when people press quit command or the Control plus backslash. There are a lot more like sig kill, and there is sig up, etc. So these are mostly not of our use for now. We'll look into the SIGTERM and SIGINT one, which are the most commonly addressed ones, the most commonly addressed signals. So this is the first step. Our application will be listening to the signals from the OS. The second step is perform tasks, or let's call it cleanup. Perform cleanups. By that, what I mean is we should complete the requests. So the thing is, we will stop accepting new requests. So stop accepting new requests, but we are going to complete the ongoing requests. If there are some files that have been opened, we'll close them. If database connections are open, we'll close them. So basically performing cleanups. We have already talked about it here, so let's not repeat, but this is the idea. We perform all the tasks that are required to be done during the graceful shutdown. And then the third step or actually these two steps are combined, would be to have timeouts. Now, what I mean by timeouts, you would have seen it with all the web apps. So basically, if the client sends a request, we cannot wait till eternity for the server to respond, right? If the client sends a request and we wait for 10 seconds and the server doesn't respond, we time out the request. We don't wait for server to complete the request for ages and ages and then get back the response, right? So that's the same idea here. We do not want the cleanups to take eternity since it is very urgent. The application is about to get shut down. We need to perform tasks quickly. So all the cleanups that we are doing must be done within a time period. If that is not being done, then we'll just cancel it out. Like if the current requests that are being completed, they take a lot of time, we are going to have a timeout. After that, we are not going to perform those requests. So here we will have a timer and we will force stop all the requests after that timer. So this is basically how we are going to perform a graceful shutdown. Now let's see this in code itself, so it will be more clear. Let's call it graceful shutdown. For this, let's create a new file. Let's call it main.go. So first, let's create an application where we will not have graceful shutdown and see why it cannot be good at certain times. And then we'll implement graceful shutdown. So let's call package main. Let me initialize the project. Go mod init. Let's call it github.com/1.7, then graceful shutdown. And I'll be using Gin for creating a server. So let me import that. This is how we import it. Gingonic. So now what all things do we need? Now let's just keep this example simple. Let's not create an entire application which will then talk to a database and store the user data in the database itself. Let's keep it simple. So let's say we are going to have DB, which will just be a slice. So the DB will be for DB of users buying the product will be a slice. What will be the other requirements? Obviously, product struct you will need. And then since user is buying something, we need to have the account balance for the user. So let's have it as a map since we will have multiple users. So map of user balance. So for DB, let's have a slice of order and the product stock, let's call it order, inside which we can have firstly product ID, product name, what is the amount of that product or the price. Yeah, I think that should be enough. Let's call it order only. This will be a map of user balance where we will have user ID, and corresponding to that we will have the balance. Yeah, I think this should be it. Let's implement and let's see if there is anything else. So let's create an order. In that we will have ID. Let's call it int. We will have name of that order. We don't even need name actually. Let's just call this order as a car. So we are going to order cars. And then we can have a price, which is int. And then our DB, this is our DB, which will be a slice. Let's call it order, and which will be a slice of car. Then there is user balance. So this is nothing but user balance. It's a map that will be having int as key, and then balance can also be int. So let's just keep it this way. Now initially the user should be starting with some amount. So let's say initially the user balance is for user ID 1, it is going to be this much: ones, tens, hundreds, thousand, 10,000, lakh, 10 lakh. So user 1 has 10 lakh rupees. User 2 has 20 lakh rupees, and user 3 has 30 lakh rupees. Actually, let's take this to an init func. Right, so initially this is the user balance and the DB is initially empty. So orders is just an empty slice, car. Now let's start implementing. So we are going to create a GIN server. Let's say r gin.default. Let's keep it simple. And then R will have some handlers. So for /by this endpoint, we can have a handler. Let's just create it here only. Yes, we do need context. And then we can just run this server. Let's say port is 8080, and we are going to run this on this port. This way. Yeah. So let's start executing by. For sake of simplicity again, let's say user ID will be 1. So we are going to talk about this particular user. Let us say step 1, order is starting to be processed. And then the step 2 would be that we will add the order or car in the DB. Let me think again. But how we are going to say this car belongs to this particular user? So for that, we'll need another thing called user ID. So now this user ID will be 1 for this car, so that this car belongs to this user. Okay, so add the car in the DB with user ID 1, and then the step would be to deduct money from user's account. Yes, I think that is it. So let's do that. order is starting to be processed. Let us say we are executing order. If I'm doing any spelling mistakes, please ignore that. I'm not taking care of grammar right now. So we are executing order for user. Here comes user ID and the amount that user has. User balance is this much and amount of car is, let us define price here only. Let us say price is 10 lakhs. So 1, 10, 100,000, 10,000 lakh, 10 lakh. Yeah. Not amount, price for the car is again percentage D. The first one was user, which is user ID. Second one was user balance. User balance for user ID 1. Let's say user ID. Yeah. And then the price. \n for new line. Now the step 2 will be to add the car in the DB. So for that, we can just say new order, new car is equals to car and then ID. What is the ID? Let's say 1. Doesn't really matter. Price, we just set it here, price, and then user ID. So this car belongs to this user. And now we can simply say our order, this is our DB, right? Orders, not this, append new car, not this, new car. And now, oh sorry, we can just print again. Print def. We have added, or just say order edit percentage %v and the orders. This was new car. Yeah, so now we are going to deduct money from user's account. So user balance and the user ID. No, what is this? User ID minus equal to the price. And again, fmt.println money deducted from user's account. Yes, so this is done. Oh, so we didn't send back any response. So what was it? Context ctx.json. We are going to send back http status okay, http, sorry for that, http status okay, and we are going to say begin.h. What should we send back? Let us say message, the order was successfully placed, message, and let's just also give the car, not this, new car. And this looks good. Let me close this. Let me close this. So we did give user ID, price, doesn't matter. This is the new car. We have added our car in the DB, subtracted the price, send back HTTP status OK. This looks good. Now let's create another one for checking the status, not post. This will be get. Let's say my cars. Again, func. We will give context, which is, or let's just say C, which is in dot context. So what we are going to do is we will check the DB. So for index and then value in orders. This doesn't really matter. We can simply say c.json and then status. Okay, http dot status. Okay. And we can simply say message fetching the cars, fetching your cars successful. Doesn't make sense, but anyways, let us say the cars that we have are just the orders, and we would want to check our balance. So balance is the user balance and user ID was 1. So let's just directly say 1. Let's complete this also with fmt. Printf, let us say order percentage, not s, percentage d, percentage d, and then amount or price for this is again percentage d. So this will be the order O and then O dot price. Let us also do \n. Am I missing \n anywhere? Let's do here also. This is println, so it is fine. This looks good. I think it should work now. Let us see if we get any errors. Go run main.go. Okay, cannot use so we didn't add range over here. So we are going to do for index value range over orders. fmt order is this. What is wrong now? Car has no field price. Okay, this is capital P. Okay, this is also small h, capital H. Now this looks good. Let's run it. It does run. Now what I want to do is I want to make a request to /by, and then I want it to add the stuff to DB, but then end it in the middle, so that we can simulate the condition where the request will be starting and we will talk to the DB, we'll add stuff to DB, but the request gets cancelled middle way, or the application that we are running crashes middle way. What happens at that case? So I want this step to get delayed. So let's say fmt dot println. No, actually, why are we printing anything? Let's just add a sleep. Let us make it sleep for 5 seconds. Yeah. So when we execute this particular endpoint, then it will add the car to the DB and it will wait for 5 seconds. This is where we will press Ctrl C. So it will end over here only, and then the money will not be deducted from the user. So what we want to show here is the car will be owned by the user, the car will be shipped to the user, but the money was not deducted. Let's close this, run this again. This is running on 8080, so let us make a call request to HTTP localhost 8080. What was it? What was the endpoint? /by. That's it, right? We are not sending anything else. No, we are not. So let's execute it. Okay, so we didn't give post. Let us see now. So it does get successful. Nice. Let us check over here. So this is how we will do it. Here I'll execute it. And as soon as this is done, we are executing. This will run. We will do orders added. After that, I need to cancel it. So running this again, order added. Let's cancel it here. So order added came and then we canceled it. So this didn't get executed. Nice. Now we can check the status through this particular endpoint. So let's do that. Curl -x, or just do curl. Let's copy it. My cars. Okay, so we have closed it, obviously, right? So now the application got shut down. Let's restart the application. And when we run curl, what do we see? Cars shows empty. The thing is, when we close the application and we run it again, then obviously we are not running this. So we are directly starting from here, and this just checks order, and order is initially empty because we didn't run this. Okay, so how do we solve this? Yeah, so after some time and some work, I figured out a way. So what we are doing is we are going to save stuff into files. So now this is not our DB. Our DB is this particular file. This is just a field in DB. I actually went way ahead in this, but then I just deleted all the code and let's just keep it simple for now. Yeah, so what is happening? Let me show you the code. This remains same. We just are going to create this file called data.json, and this file data is needed so that we can marshal and unmarshal data into the file and from the file. Everything else remains the same. We have just created a save to file and load from file. I hope you understood why are we doing this. We are doing this because if I run go main and if I execute that command, it runs fine. I exit it in the middle. When I restart it and I go here, the problem is everything is restarted. So this again becomes 0. The order becomes empty. And the user balance is this. And the order is empty, like I said. And what else? Yeah, user balance is this much only. So it didn't make any sense. So we need a way to persist our storage beyond our application, which is normally the case with production applications. So this is a good simulation for that now. Yeah, we are saving file, we are loading from file. That's it. Just basic marshalling and unmarshalling of data. So what we will do is, whenever someone comes to buy something, this is the user ID, this is the price of that car. So this does nothing. We just create a new entry For car, we add that to orders and then we save it to file. Save file is basically picking these orders only, which is now updated, and username is also updated. User balance is not updated, but it can be updated later on. So yeah, this is where we save to file, and then after we update the user balance, we again do this same thing. So at this point, the user balance will be saved, and then we just send back this response. Similarly, when we try to get our cars, this remains the same. The only thing that changes is we are going to take data from the file. So now if we execute it, I've tried it already, so it's working fine. Yeah. So if we execute this thing by car, when we execute it, we will get order added. Order has been added. Let us cancel it here to simulate the condition that the request was failed in the middle, or the application got shut down in the middle of request being processed. And then when we check my cars, obviously this is, the application is not running. Let us run it, and now let's check my car. What we see here is we have a car added, but our balance is still the same. See, if I go to data.json, this is our order and this is our balance for now. But what happened here is, initially how much was our balance? This was 10 lakhs. We purchased a car which was worth 10 lakhs, but still we have 10 lakhs in our account and we also have the car, right? So this is what can happen due to immediate shutdown, without gracefully making sure that the requests that are running as of now, let's complete them. So this is how the immediate shutdown works, and this is the disadvantage of immediate shutdown. Now let's add graceful shutdown to it. Before that, let me make sure that the recording is happening. Yes, it is. Now let's try to implement graceful shutdown in this. So for that, I think the handlers remain the same. We don't want to change them. We just want to make sure one thing here. By the way, if this exits, we should have a fmt, a printing statement, a log that says server has exited. So we'll do that. But what we want to do for now for graceful shutdown is we want to make sure that the application completes a particular request before this is ended. By this I mean the application is ended, the application is terminated from the terminal. Before that, we want to make sure that if a request has come, we will complete it. So the step one will be to make the application listen to such signals. And how we do that? In Go, we have something called os.signal for this. So it will import OS package, yes. Now what we want to do is we want to create a channel. So let's call it SIGChan. We want to store signals in this. So chan os dot signal, and size, let's say 1, doesn't matter. So yeah, we are going to use a channel for this. If you do not know how channels work and how Go routines work, then I would suggest you to watch a video on Go concurrency and Go routines that I've made. You can check that out on this channel itself. But if you have your basics clear, then we can just move ahead. So we are going to create this channel, and now we have created a channel. We want to make sure that signals come to it. So for that, signal, we'll have to import signal also, dot notify, right? I'm not sure. Notify. Yeah. So the arguments are, we give it a channel where we want to send the request, not channel, this will be SIGCHAN. And what all signals are we going to send? So for now we are doing Control C. For that the channel is called SIGINT, like we said. So it will be syscall dot SIGINT, SIGINT. I think this should be good. Let me explain you what's happening here. So what we are doing with this is, if you look at SIG channel, this is just a channel. So always think of channels like a box from which we can, in which we can enter stuff. We can put some stuff in the box and we can get some stuff out of the box. These arrows are important. Why do I put them this way? Because this is how channels work. We always have these arrows in channels. I hope you know that. So what we are trying to do here is, using signal.notify, we are saying that whenever there is a signal generated by the OS called SIGINT, the SIGINT channel, the SIGINT signal, whenever this is generated by the OS, we want to put that signal inside SIGCHAN. So this is a box called SIGCHAN. This has size as 1, so only one thing can fit inside it. So what happens is, this is signal.notify. What this does is, whenever there is a signal called SIGINT, whenever there is SIGINT generated by the OS, SIG-notify will make sure that we add that into the channel. And from here, we can get this SIGINT and we can perform tasks on it. For example, let us say one more here. SIGCALL.SIGTERM. Yeah. So that we can use this in our switch case statement. Now we will create a Go routine that will be running concurrently. So we'll say SIG. We'll say whatever is coming out of SIGCHAN. Whatever is coming out of SIGCHAN goes to SIG. And that's why we use these arrows, and that's why I use these arrows, because only one directional arrows work in Go. So if you remember about, or if you learn channels this way, it will be much easier for you to remember. Now let's say whenever this happens, whenever anything enters SIGCHAN, SIG will get value of that, and we will execute this statement called, let's say, signal for control plus C received. Actually, we should not be creating a switch case statement, so this will never happen. This will never occur in our case, because anyways, even if this occurs or even if that occurs, we are anyways going to perform graceful shutdown only, so it doesn't really matter. Even if we create a switch statement, both of the cases will be same. Even if this is the case or this is the case, in both cases we are going to do the same thing, which is graceful shutdown. So you can remove this as well. This serves no point for now. So we did receive a signal here. Let's also say that we have received this signal, \n also SIG. Now, why will this be executed only after this? I hope you know that already. This statement is acting like a blocking statement. So unless this becomes true, nothing will be executed after it. So unless something is entered inside the SIGCHAN, this will never be printed. So only after this is done, signal for control D received, this will be printed. That's why we are doing it this way. So now let's create a context so that we can do timeout. Let's say cancel. we'll need to import context. Let's say with timeout. We will create a context using background, and we will give timeout to be 10 seconds. Defer cancel, so that after this function is run, cancel is executed. And then we can simply not have a switch case statement. Let's directly just say server or r.shutdown. No, actually we didn't create a server, right? So we'll have to do that. Instead of doing it this way, we will create a server using HTTP. So we'll create an HTTP server. This should be ampersand here. I think it is address. Yes. The address will be port. Let's do it this way. Let's remove. Let's not remove this. But this is already defined, right? R has been defined over here. So we can remove R from here. And we can say handler, and which is R. So this should be fine. And now that we have a server, we can say server dot shutdown, and we can give it context. This will return us error. Then let's just say it failed or something. Graceful shutdown didn't work. And if it does work, then we will say gracefully shut down the server or the application. That's it, and we will execute the go routine. And now we need to execute the server as well. So server will be here. If we put server here, then the server will first start executing. Go routine will start being executed, and since there is nothing over here, main execution will go, like main execution will be completed, and this will never be running. So server must be here. Listen and serve. Does it return something? It does return error. So let's just say some random stuff now. And once everything is executed, we can say server exited gracefully. Right. So now let's see. Let me close this. Let's see it from the beginning. There are no changes over here. This is where we create the handler. These are the handler funcs. Handler func again. Port has been defined. Created a server this time. We have created a channel which will be listening to signals, and we'll make sure that notify will give us signals on SIGCHAN. Which signals? Whenever there is a SIGINT or whenever there is a SIGTERM. If we look at the implementation, it says notify causes package signal to relay incoming signals to C. By C, we mean this channel. So if no signals are provided, then all of the incoming signals are relayed to C. So that's interesting. If we do just this, why does M come here? This is also fine. In this case, all sort of signals, if any sort of signal comes, then notify will make sure to add it to SIG channel. And then we are running this as a go routine. What is happening here is whenever any value enters SIGGEN, it goes to this variable. This print statement happens, and then we are going to create a context with timeout, and then we are going to shut down. Now what this shutdown does is, it does one, stop all the new requests. It will stop entertaining all the new requests. Two, it will continue executing the requests that have already been started. And it will also respect this context since we have given a timeout. So if a request takes more than 10 seconds, it will be timed out. I hope we haven't given like a crazy number here. Yeah, it is 5 seconds only, so it will be fine. And then graceful shutdown happens. If any error occurs, we point that out. After that, we say gracefully shutting down the application. And once it is completed, we just say this. But this will be executed anyways, even if it's not a graceful shutdown. Yep. Yeah. So this should be just removed. Now let's try to execute this. Let's close it, run it again. Syscall has been imported and not used. Okay, so earlier here we were using syscall. Now we are not using it. Let's actually use it only. Syscall dot sig int. This is the one we care about right now, because this is the one that is called whenever we do Control-C in the terminal. What's wrong here? Yeah, this should be printf. Now let's run it. Before that, let me just delete this file. Let's run it again. Okay, so now I need to execute by command. So I'll execute by command, and this has been saved to file. I'll cancel it. This does give me the error. Let us see what happened to the file. Let us run my cars. Okay, again the same mistake. We need to run the application first. So there is still some issue. Graceful shutdown is not happening because the balance still is 10 lakh and the price as in the car is added. So it was stuck in the middle again. What is wrong? We kill it at this point. This is still not executed. What happens is main function runs, all these things run, we don't care about it. We create a channel, notifies, so whenever we do Control-C, notification comes. See, signal for Control-C received. So this did run, but this didn't run because you don't see it. Why? But this did run. So this did run and directly this ran. Okay, I think I know the reason. The reason is that this go routine could have worked fine, but the main function is itself exiting because the main function's execution is over. So the main function exits and then this is of no use. So we need a locking mechanism here. Let's do that. Let's create something done. Int, let's say 1. Okay, so this doesn't matter where we put it, but before ending we need to make sure that there was a value inside done. So value should be inside done. Where should we put it? Let's put it here. Or actually let's put it after this is executed, so that everything is executed. Only then we release the lock, sort of. Let us say 1. Okay, so now Only when this is executed, we will reach here. And once we reach here, after that we can say graceful shutdown completed successfully. Now I hope this works. Okay, clear it up. Go run main.go. Let's run by. It is going to be saved in file. Before doing that, let me actually delete this. So I think it is working because it does show me graceful shutdown completed and all. Let's run it again. Go run main.go. Let's run by and let's make it end right here. But you will see it does not end immediately. It first says we received a signal. It runs this command, this lock, and then it says money deducted from user's account. So this is this particular line. So it does execute the entire request. Even if we shut it down in middle, it will make sure that it runs the entire request. And after that, it will run this command. At this point, the user or the client gets back a response called 200. And after that, we reach here. Here we do see gracefully shut down the application. So we see it here, and then we put the value inside done. So now this can be executed, and then this is executed. So I hope you realize the format. I hope you see that why the format is as such. First this runs. Why? Because we just came down till here. This failed, so it came here. And then after that, this is the locking statement. This won't run until we get to this, right? So to run this, we go here again. So then this is executed, signal, then we create a context, and then we do shutdown. Like I said, this is for graceful shutdown. This makes sure that any new request will not be entertained, but the existing requests that are being processed, they'll be completed. Hence, it makes sure that the execution goes back up here, and this was already done. So this started executing, this got executed, a response got sent, and we came back down. After this, we came back down here, gracefully shut down the application, gave the value to done. Once it got the value, it started running this or showed this log, and the main execution got completed. So this is basically how graceful shutdown works. And this is why we need graceful shutdown, so that our applications, our requests are not ended in the middle of execution. Yes, new request should not be entertained, but the request that has already started being processed, they should not be left in the middle. That's what graceful shutdown makes sure in this case. And not just this, we can have other things as well with graceful shutdown, like making sure that the DB connections are closed properly. We can do some cleanups. Like in this case, we can clean up this data.json file, and we can have any sort of implementation that really depends on what application you are trying to build and what sort of shutdown or what sort of graceful shutdown you want. But this is basically the idea. So I hope you understood what graceful shutdown is. I hope you followed through this example and you were able to see why do we need graceful shutdown and how graceful shutdown is implemented in Golang. So this was it. Thank you for watching this video. I hope you found this helpful. If you want to watch more Golang videos, you can check out my other videos on Golang. In either case, thank you for watching this one, and I'll see you in the next one.